Hi, my name is Andrew Banson. I'm an application specialist at Civil Survey Solutions. The aim of this video is to provide a technical overview of civil site design on the AutoCAD Civil 3D platform. Using this Civil 3D drawing, I will create some roads, curb returns, I'll do some road reconstruction design, and I'll work on a rural road design too. This session will also include the output of volumes, long sections and cross sections, and also some 3D visualization. So when you install Civil Site Design for Civil 3D, you'll see a few extra tabs appear on the ribbon, those being Site, Roads, Pipes, Data Share, and General. So for the most part of this session, I'll be spending time in the Roads tab, which is quite an intuitively laid out tab. Creation tools towards the left, editing tools towards the center, and outputs towards the right hand side. In this drawing, I have some Civil 3D alignments which I'll use to create some strings or alignments that might be used to control the edge of my roads that I create. And I also have a Civil 3D surface called NS that I will use as my sampled surface. So the first thing I'm going to do is create a typical shape for some road. So the command I'm going to enter is called create edit section, and this is the window that appears. Templates in civil site design are either local or global, and when you install the software, it does come with a whole bunch of pre-made templates, different curve, road shapes, etc. So the difference between local templates and global templates, the local templates that are stored in this particular project and global templates are stored externally. And if I save templates to the global area, the global library, then I can use them for future projects. When I click on the template options button, you can see that I can create a new template in the local library and use for this project. I can create a new template in the global library and use for future projects, and I can also copy templates between the local and the global. So what I'm going to do is create a new template in the local library, and I'm going to call this one Standard Urban. I have a completely blank template. There's this one code here called C.L. which represents the alignment that my string or my template will be anchored off. So there's a few ways to build up a template. I can fill out this table, and how this works is the blue cells represent sections working out towards the left, and the white cells refer to building sections out towards the right. So a section or a leg will have a horizontal distance, a slope or vertical distance. If I tick on plot yes, then this code is seen as important and will be shown on cross-section views and will be detailed on the cross-section output. And then we give a name, a code name, and codes on the left should be prefixed with L and codes on the right should be prefixed with R. So although I can build a template by filling out this table, the easiest way to build a template is by using these commands on the right hand side. Create section will allow me to build a section for both the left and the right hand sides of my template, and at the same time define up to 10 layers of subbase. The create curb allows me to quickly create some curb shape. When I've built the template, I can apply batters, standard batters, by using the left side or right side buttons under create batter conditions. So to build this template, I'm going to select on create section. The code for this template will start at EB. This is an important code in civil site design. EB is known as the connection code for when we build curb returns, cul-de-sacs, bus bays, etc. So by default, I would recommend using the code EB, although if you don't like using EB, you can go into the settings and change it. So EB will represent my edge bitumen. The width I'm going to set at 3 meters and the initial slope -3%. So I can set up to 10 layers of sub-base. I'll go for 30 mil of asphalt, 100 mil of crushed rock class 2, 200 mil of crushed rock class 3. And you can add your own materials to this library as well. If I tick on plot code, as I said, this is an important code that will be shown on my cross-section outputs. So if I click OK, I've built 2 sections, one for the left and one for the right, and I can edit the horizontal distance or slope by just editing directly in this table here if I wanted to. If I wanted to edit the subgrade information, then I click on Edit Section and then pick anywhere between 2 codes. I can then go through and edit the subgrade layers. Next, I'm going to add some curb, so I click on the Create Curb command, and I need to define the invert, topper curb, and backer curb. And we're attaching the curb off our edge bitumen code. One of the nice things about civil site design is these interactive images that appear as you hover your mouse. So as I'm filling out this table, I can confirm what each of the values represent. So for the width of the invert, I'm going to say 0.3, the depth -0.04, and the code will be I and V. Topper curb, I'm going to come across 40 mil, up 150, and call this TK. And backer curb, width 110, depth 0, then we'll call BK for the code. Curb depth, I'll set that to say 0.2. The sub base will extend 0.15 behind the curb. I could put a slope on the curb or the sub base, but I might just jump straight down and define a subgrade thickness of 0.13. We'll say that curb material is concrete, and we'll put some crushed rock underneath that. Now, each time you work on a design, you don't have to build these templates up from scratch. The easiest way is to bring in a pre-made template and make some adjustments to it. So I now have some curb, and I'll say that LTK is my plot code. The other thing to remember is at this point in time, this is my typical shape of the road. So it's not to say that my entire road has to be 3 meters at 3% slope. Later on, I'll show you how we can make variations to the road or the string that we're creating. So I'm just going to create a few other sections here, one for the footpath or the inner part of the footpath. And I want to create the footpath itself. And put some concrete underneath that. The beauty of defining all the subgrade layers, thicknesses, is at the end of the day I'll be able to output some material totals. Okay, so I've got some footpath. So my template's pretty much done. The last thing I'm going to do is to find some standard slope conditions for the batters. So 1 in 4 for cut, 1 in 4 for fill. Alternatively, I could have a fixed width batter. And once again, if the batter does change through different chainage regions on this string, I do have the ability to override that. So that's pretty much how you go about building a template. It's pretty straightforward. There is a little bit more detail we can get to get into templates, but this is a nice start for us. So I'm going to go and click OK, and now we'll go and build some roads. So in civil site design, we use the terminology of string for any alignment that stores vertical data. And the most common string is a road string, but we have curb return strings, cul-de-sac strings, knuckle strings, which are used for bus bays, roundabout strings, and just a very standard profile string. Now, road strings and network strings have some intelligence. If I create two road strings that join, then I form an intersection. And if I move the levels of the main road, then the side road will automatically move to reconnect. Network strings also have a lot of intelligence. So I'm going to start off by just building a basic road string. So I select the alignment that I want to use, and then this dialog box appears. The string type is of road. The template, I'll pick the one that I just made, and the surface we're sampling is the natural surface, the Civil 3D natural surface. I then specify some standard section sampling at the tangents, arcs, and spirals. I do have the option to add in extra sampling using a number of different methods. If I click OK, then that road string has been created. Two things have happened. Firstly, the vertical grading editor has appeared, and the software does a design of best fit over the natural surface. Secondly, I have some line work appearing in the drawing, and this design line work will update as I'm making changes to my design. If I move my mouse inside the vertical grading editor, you'll see a green tracker appear, so I know where I am in plan. If I right click the mouse, I can open up a cross section. If I zoom to the cross section in plan, you can see I have also a tracker along the cross section, so I can see all the elements of my section also in plan view. If I scroll my mouse on the ribbon, then I can actually quickly scroll through all my cross sections along the road nice and quick. I can also open up multiple cross sections by holding down Shift and right clicking, and you can open up as many cross section windows as you want. If I'm making changes to my vertical design, then you'll see the cross section windows update straight away. So while the vertical grading editor is opened, I'll run through some of the tools to insert IPs, delete IPs, and edit IPs. Quite often the first thing I do when working on a vertical design is hit the delete all IPs button. And what this does is just add an IP at the start and an IP at the end. Now if I want to insert a new IP, I click on the add IP button and I select where I want to add the IP. Using this form I can set the exact chainage level, vertical curve length, etc. Normally I'll just click OK and just add some IPs roughly where I want them, and then press escape to exit the command. So to edit an IP, there are two methods, well three methods actually. The first one is by simply left clicking on the IP, and then from the ribbon I can make some changes. So maybe I want the chainage to be 80, maybe I want to put a vertical curve length of 40, and then I just select on apply. You'll see that change made. So I might just quickly go through and add some vertical curves to my IPs. Now you'll also notice as I'm working on my design, we can see the total cut and total fill updating. Now there are some other useful commands in this IP editor. The first one is a simple delete, so I can click on an IP and delete it if I want. And the other one is this one, which allows me to match the IP to a reference. Now on the Home tab, the current reference is set to NS, the natural surface. And so if I was to click on the IP, I'll just zoom in a bit and select on this button, you can see the IP is matched to the surface. Now I can actually add other references, we call these design constraints, and add IPs that reference those as well. Another way to edit IPs is by using the grid editor, and the grid editor will list all my IPs, their level, grades back and forward, and the vertical curve length. And you can also use the grid editor to add extra IPs as well. So I can just start typing in where I want an IP and hit enter, and it'll add the IP for me. I might come back to the grid editor when I do the rural road design, just to show you a few extra tools that are available. So I mentioned design constraints. These are really useful, particularly for road reconstruction. I will give you an example of those when we do maybe some curb replacement down at this part of the job. So for the time being, I'm going to close the vertical grading editor, and I'm going to create another road string, and I'll just use the same template. Click OK. So I now have two road strings, and I know that I have an intersection between those two roads because a red line will appear where the alignments intersect. So if I was to open up the vertical grading of my main road and move the levels up and down, alright, you will see the levels of the side road also update. Now, because I have this intersection being formed, I can now add curb returns in automatically, and you'll find this curb return command underneath network strings. So to add a single curb return, I click on the curb return command, pick where I want to add the curb return, and the following window will appear. I can name the curb return, can specify what template I want, what default batter conditions I want, and the matching code, which, as I said, is an important code that defaults to EB. In regards to the alignment geometry, I can create the curb return at a single arc, or maybe I want some compound geometry. The other option, which is quite powerful, is the option to use your own alignment that you've drawn, and I'll show you that a bit later on. So I'm just going to create a single arc curb return at a radius of 10. Click on Create Update, and that curb return has been added. I'll tick on this option to show the vertical grading editor of the curb return, and here we can see the vertical geometry of the curb return. Now, what will actually happen is, as I'm moving the main road and side road, in fact I might just show you this, if I was to go and make changes to either side road or the main road, you'll see the curb automatically updating, so it's automatically redesigning. Now, if you want to turn that behavior off, you can. You just simply tick on the auto design button here, and you set the design to keep internal design, which means you have the power to design that profile however you like. You can click on IPs and remove them. Now, so that you're aware that you are now in charge of that profile, or that string's vertical design, we display this symbol here with the two white circles, and that's telling you that you have control over the vertical geometry. But you can always switch back to the automatic design if you wish. So I'm just going to create another curb return for the other side, and I might make the radius a little bit bigger this time. If I wanted to edit the radius of any curve return, then I simply go back into the curve return command, click on the curve return, and I can make the required edits. So by clicking the Auto Model command, the software will build for me a design surface. This design surface will update as I make changes to the horizontal or vertical geometry. So what I'm going to do is reopen the vertical grading editor, and I do that by clicking on Open Vertical Grading or Vertical Grading, clicking on the road or string that I want to edit, and the vertical grading editor will appear. So beforehand you saw me edit IPs by either left clicking or by using the grid editor. You can also edit IPs graphically by using these icons. This button here is Move IP Anywhere, and I simply click on the IP and I can move it wherever I like. As you'll see, when I confirm the change, the design surface updates. This option will lock the chainage but allow me to move the IP up and down. This one, slide IP on grade, is really handy. It allows me to slide the IP by maintaining either the in-grade or the out-grade. This one here will keep the level but allow me to move the IP to the left or to the right. There's a whole bunch of useful editing tools. We can edit IPs over chainage ranges or delete IPs over chainage ranges. We can do an automatic balance of the earthwork, so I can tell the software to balance my design so that cut equals fill. So there's lots of useful tools here to explore, but I think that covers most of the basics of the vertical grading editor. Okay, so the next thing I'm going to do is just some very basic cross-section edits. To start with, I have an alignment, a Civil 3D alignment created, which is called Road 1 EB Widen, and I want to tell the software that my edge of bitumen should match to this alignment. And while I'm performing that edit, I might make a few other edits as well. Maybe we'll delete the full path over a particular chainage range or something as well. So edits to a road can be done in two places. One, the design data form, but you can also make edits directly in the cross-section view, which is what I'll do to start off. By clicking the bottom part of the vertical grading button on the ribbon, I'm going to select on Open Cross-Section Window, pick on the string and the chainage that I want to open. So here I have a cross-section for the string at this particular chainage. Couple of things. Under the Display tab, I can change the exaggeration, so maybe I want that to be 2, just to flatten it out a little bit better. I can also add extra objects to the view, so maybe I want to see the alignment that I'm going to widen to, and that can be done by clicking on this button, and I simply say for all strings I want to show an alignment, which is Road 1 EB Widen, and I pick the chainage range that I want to see that for. Okay. The first button is the viewer settings, and this allows me to customize what I'm looking at. So maybe I actually want to see the code names along the template. Maybe I want to see the offsets, the levels. Currently what we're looking at is the cut and fill information across the cross section. As I hover my mouse down the bottom, I can see the code that my mouse is at. Now what I want to do is edit the LEB code and add a variation to match or widen it to the alignment. So I simply right click the mouse, select on Add Variation, Modify Section, and select the Match Code to Alignment variation. This section design editor will appear, and I simply specify the alignment that I want to reference. If I didn't want to do this over the entire length, then I can also set the exact chainage range that this occurs. If I click on Apply, then you will see the variation applied and the model updating. So you can perform a lot of edits this way directly in the cross-section viewer. Maybe on the right-hand side of my design, I wanted to remove every code behind the backer curb. So I'd simply right-click the mouse behind the backer curb, add variation, delete section, and this time I'm going to use delete sections behind code. Click apply, and that edit has been performed. If I want to get an overview of the edits applied at this particular chainage, then I simply right click the mouse and select on Open Section Design Data. So for this chainage on road 1, I can see the 2 edits that I've made, and I can make edits to those.